Okay, yesterday, we went over ionic compounds. We quickly talked about how they work, that they're a metal and a non-metal, that their bonds are very weak and that they involve the changing or trading of electrons, where non-metals are taking the electrons, metals are giving them up. That's why metals are positively charged, non-metals are negatively charged. We talked about the naming rules. So you have this formula, you write the name of the metal, you write the name of the non-metal. There were a couple here that we didn't do, 11 through 14 I think we didn't do. So just to see how much we remember from yesterday, I want you to try 12 and 13 right now. We'll use that to kind of review our naming rules, and then we'll move on and review the multivalent metals review the polyatomics and the multivalents. All right, on number 12, what does SR stand for?
Strontium.
Strontium. Okay, so we named the metal first. Whoa, I don't want the thick anymore. Okay, strontium. Okay, and what does I stand for? Oh, yeah, good, very good. Iodide, yeah. Okay, no prefixes needed. These are ionic compounds. That's the only way strontium or strontium, can go with iodine. By the way, there are two ways to say that one. Okay, number 13, what would we be looking at there? What does Ca stand for?
Calcium oxide.
This will be calcium oxide. Okay. At the end of class yesterday, we started talking about what happens when you have a compound that, say, looks like this. It clearly has more than two elements in it. If it starts with a metal but has more than two elements, then you know that you have something from your table of common polyatomic ions involved. The naming rules are exactly the same. I write the name of the metal, and then I write the name of the polyatomic ion, exactly as it appears up here. So that stuff would be lithium nitrate. Ringing a bell from yesterday? The nice thing about the polyatomic ions is you don't have to change their name. You just write their name exactly as it appears up there. You don't have to make them end in I or anything like that. All right. Now, did we get to this at the end of the day yesterday? I think we did, but now I'm not as sure. Did we talk about multivalent metals and the Roman numerals? Yeah, just briefly, right? Okay, so the problem with some metals is there are some metals that give up different numbers of electrons based on the type of that element that they are. So for example, copper can come in two forms. Most copper is copper that loses 2 electrons and would have a 2+ charge. There's a very small amount of copper that's slightly different that for whatever reason only loses 1 electron. That would be copper 1. What we have to be able to do is communicate in writing, in the name of something, that these are not the same compound, because otherwise they both look like this. Copper sulfide, not oxide. Copper sulfide. I think that was the example we used yesterday, if I recall. So copper sulfide and copper sulfide. And then I told you the story about how I had 2 people with the same name in my class, like exactly the same name. Obviously that's not good. We need some way to be able to tell these apart. So what we do is we figure out what the charge on copper is. And we do that by using the non-metal. Because if you look on your periodic table, there aren't any non-metals with more than 1 charge listed. They're in a certain group, they have a certain charge. Everybody follow? What group is sulfur in? What number? 1 at the top.
16.
It's in group 16. Yesterday we wrote the charges for those groups. What's the charge for everything in group 16?
-2.
-2. All right, so we know that sulfur is always a -2 charge. Copper could be a 2 or a 1. But now at least we can figure it out, because we know one thing about all ionic compounds. Their overall charge is 0. The positives and the negatives have to balance out in a true ionic compound. Okay, so in this top one here, I have 1 sulfur and it's going to take 2 electrons. I only have 1 copper. If this thing is going to end up with an overall charge of 0, that copper has to have a 2+ charge. Agreed? Okay, so did you sign in? Thank you. Okay, copper 2, okay, sulfide. I would just put in the Roman numeral for 2. Okay. All right, and then for this one here, okay, I still have sulfur with a -2 charge, because that's the only charge it ever has, okay? But in this case, I now have 2 coppers, okay? I need to get 2 positive charges, but I've got 2 coppers to get it from, which means each one must have a charge of 1, okay? So you have to do a little bit of math, okay? Not a huge amount of math, but a tiny bit of math. Okay, so this stuff would be copper 1 sulfide. Okay, just put a little Roman numeral in there. Okay, we'll practice that a bit. Okay, so multivalent metals. Okay, we call the metals that are kind of in the middle of the periodic table there transition metals, because we're transitioning from very, very metallic things to non-metals. So they're in the transition area in between, okay? So they can give up different numbers of electrons, okay? So to do this, we use a Roman numeral to denote which one is which, okay? So that's what we just did. I'm gonna do another example here, and I'm gonna want you guys to kind of copy it down and kind of follow along with me as we do it, okay? So here's my compound. Fe2O3. Okay, I can start out writing the name of this, no problem. Okay, I can start out by going Fe is iron and O is oxygen. So this is going to be iron something oxide, because if I look at my periodic table, I can clearly see that iron can be a 2+, or what's the other charge? 3+. Okay, so I've got to figure out, is this the iron that's the 2+ iron, or is it the iron that's the 3+ iron? All right, we always start with the non-metal when we want to figure that out, because there are no non-metals with more than 1 possible charge. So charge on oxygen is always -2, because like sulfur, it's in group 16. So I just write a -2 right here. How many oxygens do I have in that compound? 3. So how many negative charges do I have in that compound? 6. Yeah, exactly. Okay, if every oxygen can take 2 electrons, and I have 3 oxygens, I got to find a home for 6 electrons. Okay, I've got to absorb these 6 negative charges. Now, we know that an ionic compound has to have an overall charge of 0, so that means from the metal, we have to get 6 positive charges, or we have to get 6 electrons from them. Okay, so if I want to figure out what number goes right here, that is what the charge on iron is, I just go 6 divided by 2. This is iron 3 oxide. Okay, that method will work 100% of the time. Okay, you've probably also looked at that and gone, yeah, Coder, so would reversing the swap and drop. Didn't you just see that the numbers just went back up where they were before I dropped and swapped them? And I would say that's true on this one. And it's true on 2 out of 3, maybe. Okay, somewhere 65, 67% of the time, something like that, it would work. But there are gonna be cases where it doesn't, okay? And if all you do is reverse the drop and swap, you're gonna get it wrong. Okay, you're gonna put in the wrong Roman numeral, okay? At least 1 out of every 3 times. I don't know about you, but I like to be right more often than that. I'm never right that often, but I'd like to be. It seems like it would be fun. Okay, that's what we want to do. Okay, is everyone following that method there? Okay. I would like you guys to try, we already did number 1. Okay, so let's try 2, 3, and 4. Actually, we already did number 4 as well. That was one of our other examples. So let's just do 2 and 3 for right now. Okay, I'll give you a couple minutes on 2 and 3, and then we'll go over them together. Okay, so I start out like I do with any other ionic compound. I write the name of the metal. CO stands for cobalt. Okay, and S stands for sulfur, which I would change to sulfide. Okay. Once I've done this, what I want to do, no matter which ionic compound it is, I still want to check my periodic table. I'm looking for more than 1 charge in the box of the metal. Okay? In this case, do I have that? Does cobalt have more than 1 charge? Yeah. Okay, I think it's a 2 or a 3, right? Yeah. Okay, so it's a 2 or a 3. So what I need to do is that same process we just looked at. Non-metals only ever have 1 charge. So sulfur's always a -2. There's only 1 sulfur. There's also only 1 cobalt. So that means that cobalt has to have the same charge as that one. This is cobalt 2 sulfide. Okay, when they're the same charge, they're easy. Number 3, okay, Mn stands for manganese. Okay, and Cl is chlorine. So we're going to have manganese, something, chloride. Okay, does manganese have more than 1 possible charge? Right, it can be a 2 or a 4. And in this case, the choice is pretty obvious, but we'll still walk through the process. Okay, chlorine is in group 17. Everything in group 17 is a -1 charge. Okay, we talked about that yesterday, and we added it to our periodic tables. Every chlorine is a -1. There are 4 chlorines. That means I have 4 negative charges that need to be balanced. I only have 1 manganese to do that with. So that manganese has to have the +4 charge. So this is manganese IV chloride. Okay? It's a little bit of math. Okay? I can't lie to you. It's a little bit of math, but it's not hard math. Okay, well, let's have you try these ones here. Okay, so for number 5 here, okay, what does SN stand for? Tin. It's what?
I said what you said.
Okay, yeah, it's tin, right? Like SN is tin. It's a weird one. It's just one of those Latin ones. Okay, so we have tin, and it's with telluride. Okay, this is one of the ones where you need to be careful about reversing the drop and swap. Okay, we can see that tin can be a 4+ or a 2+, but tellurium is in group 16, which means it's -2. If you reverse the drop and swap, you're going to write this as tin 2 telluride, but it's not, it's tin 4. Okay, so this is one of those cases, the 1 out of 3, where if you just reverse the drop and swap, it's going to be wrong. All right, so we do what we always do. We go to the non-metal. Tellurium always has a -2 charge. There are 2 of them, so that gives me 4 negatives. I need to get 4 positives from 1 tin. 4 divided by 1 is 4. Tin, 4 telluride. Okay, questions on that one? Okay. What does Hg stand for?
Mercury.
Mercury. Okay, and At is astatine, so this is mercury something astatide. Okay, now astatide is in group 17. Okay, so everything in group 17 has a -1 charge. There are 2 astatines. -1 times 2 is -2. That means I've got to get 2 positives from 1 mercury. 2 divided by 1 is 2. Mercury, 2 acetate. Okay, questions on that one? Right. What does PO stand for? Besides police officer.
Polonium or something.
Yeah, polonium, yep. Okay, polonium, okay, and I is iodine, so we would call it iodide. Okay, iodine's in group 17, everything in 17 has a charge of -1. All right, so that means we have 4 negative charges. Polonium must be, in this case then, a +4 charge. Is that one of the possibilities? It is. Polonium IV iodide. Okay. All right. If on a quiz I gave you one of these and you didn't put the Roman numerals, you get it wrong? Yep. Okay. Just so you know, guys, on quizzes I don't give half marks. Okay. It's either right or it's wrong. If you wrote polonium iodide, it's wrong. It's polonium 4 iodide. Okay. You gotta make sure you have all of it there. Okay. SB. That's a weird one. Antimony. Okay. And sulfide. Okay. What's always the charge on sulfur? -2. Okay. And there are 3 sulfurs. -2 times 3 is -6. So I need to get 6 positives from 2 antimonies. 6 divided by 2 is +3. 1, 2, 3. Okay. Everybody okay with how those work? All right. I think I have a couple more here I want you to try just to practice those, and then we will move on. Okay, those 2. Okay, let's have a look at these 2 here. All right, so Ni stands for nickel. Okay, N stands for nitrogen, so that'll be nitride. Okay, and nickel can be a 2 or a 3. All right, so we've got to figure out which one it is. Nitrogen's in group 15, where everything has a -3 charge. Okay, so if there are 2 nitrogens and each one of them can pull in 3 electrons, that means I've got the ability to take in 6 electrons from the nitrogen. Okay, that means 6 electrons have to come from 3 nickel. 6 divided by 3 says that each nickel has to give up 2 electrons to make this work. This is nickel 2 nitride. Okay. All right, and then for our last one, Bi is bismuth. Okay, and O5 is oxide. Okay. Oxygen's always in, or is in group 16, so it always has a -2 charge. So how many negative charges do I have here? 10, yeah. Okay, so I've got -10, so I've got to get 10 electrons from 2 bismuth atoms. Okay, that means 10 divided by 2, each bismuth must have a charge of 5. Okay, it's pretty rare to go higher than 5 in your Roman numerals. Okay, ringing a bell? Or not ringing a bell, just making sense because this is new. Okay, expect that you'll probably get a couple like this on your quiz on Friday. Okay, if you have not already done any of the quizzes, I would say you should probably get after them this evening or tomorrow evening, okay, because it's a short week, right? Definitely have a look at like 1 and 2 after today's class, okay, if you haven't done 1 already. 2 is going to be all naming, 1 is all atom stuff, okay, 3 is all naming, so just something to think about if you're planning your time here. Okay. Now, before we go to that one, oh, we got to do molecular first. Sorry. Okay, let's do molecular compounds here. Actually, I'll give you about a 2 or 3 minute break here just to collect your thoughts before we start doing molecular compounds. All right, so now we're going to talk about molecular compounds. Here's the good news. There's nothing new here. Okay, all the rules and stuff you learned how to do last year for naming molecular compounds is exactly the same this year. We're not going into more complex stuff like we did with Ionic. The only real changes for you were with the Ionic compounds. All right, so naming molecular compounds, obviously we talked about this before. Molecular compounds arise when two or more non-metals react or combine to form a new substance. Okay, in these compounds, electrons are shared. Okay, now when electrons are shared, it's a different kind of bond. Okay, it's not an ionic bond, it's what we call a covalent bond. Okay, so covalent, okay, means shared valence or shared electrons. Okay, so what's happening here is instead of trading the electrons, like what happened in the ionic compounds, now the outer electrons are shared. That makes this bond really strong. They can't live without each other because the other has what they want, but they're not just giving it away. Okay, they have to stay together to have their outer shells filled, okay, in this case. So molecular compounds have much stronger bonds than ionic compounds, and that means they behave quite a bit differently, okay, which is something we're going to look at next week. All right, we do have to use prefixes, okay? Molecular compounds, okay? We use prefixes to denote the number of atoms. So this is where you'll use mono, di, tri, tetra, penta, okay, all of those prefixes, okay, that you've learned before, okay? That's what we'll be going over here. So for our first one here, okay, we would have one carbon. Weird thing about molecular rules. For whatever reason, you don't put mono on the first one, even if it's a 1.
Are we gonna go over like the prefixes?
Yes, I'll go over the prefixes, yeah. Okay, so we don't put mono on the first one, even if it's a 1. I don't know, chemists just have to be difficult, I guess. They gotta have crazy little rules to try and trip you up, I don't know. Okay, so we would just have carbon disulfide, okay, di being the prefix for 2. All right, on the next one, is there a mistake in the next name? What's missing? Mono. Yeah, I didn't put mono on the oxide. Okay, that's not dinitrogen oxide, that's dinitrogen monoxide. Okay, we don't write, I mean, you could write monoxide, but then you have to put a hyphen in there. Typically, we just write monoxide when we omit one of the O's. Okay. All right, so as requested here, prefixes, you need to know up to 10. I won't go higher than 10, okay, in this class. So 1 is mono, and you should probably write these down. 2 is di. 3 is tri. 4 is tetra. Okay, 5 is penta. 6 is hexa. 7 is hepta. Now, somebody out there somewhere, especially if you learned this in French, teaches septa for 7. Don't ever do it that way. It's very triggering for Mr. Real, and he'll flip out. He's got a really loud yelling voice, so you don't want to hear it. Okay, I don't know why it's so triggering for him, but it's really triggering for him. Okay, so hepta is the one we want to use for 7. Okay, 8 is octa. Okay, 9 is nona, and 10 is deca. Okay, those you will have to know. Okay, you will have to memorize the prefixes. I don't want to see them on your periodic table. Okay, they need to be memorized by you. All right, at this point, I want to talk about some special elements on the periodic table. Okay, you can see in this diagram up here, okay, in the top row, they have some molecules, but the molecules are made of the same elements. Okay, like we got 2 hydrogen atoms bonded to each other. We've got 2 oxygen atoms, 2 nitrogen atoms, 2 chlorine atoms. There are a bunch of elements on the periodic table that are called the molecular elements. Okay? The molecular elements are ones that actually bond to themselves. So their simplest form isn't a single atom. Their simplest form is a molecule made up of 2 or more of the same atoms. Okay? Like, for example, the gas we breathe in is oxygen. That is the elemental form of oxygen. It's actually a molecule and not a single atom. Okay? So the molecular elements, so that you know them, okay? Maybe just put like a little check mark or something in each of these boxes, okay? Starting at nitrogen, okay? You can go across this row to fluorine and down to astatine, okay? Kind of makes a 7, right? And oddly enough, there are 7 of them there, okay? So these are the 7 in the 7, okay, molecular elements. Right, so nitrogen, oxygen, fluorine, chlorine, bromine, iodine, astatine. These, when they're in their element form, come as a 2. Okay, so maybe put like a check mark with a little 2 beside it, so that you know these come as a 2. Hydrogen is also one that comes as a 2, okay? So you gotta put that little, however you're marking them, okay, I said check mark with a 2, however it makes sense to you. Hydrogen is also a molecular element that bonds to itself to make a molecule. Okay, there's only 2 more, but they're weird, okay? Phosphorus comes as a 4. Okay, so when phosphorus is by itself, it's actually a molecule made of 4 phosphorus atoms. Okay, so you got all these ones that are pairs, then you have a tetrad, and then you have sulfur, which comes as an 8. It's an octet. Okay, those are our molecular elements. Just telling you those because we're talking about molecular compounds. The bond is the same. Okay, we won't actually need to know which ones those are until we talk about reactions, but we're just identifying them so you have them on your periodic table today. Okay, let's see what we remember from last year. Okay, I want you to write the names of those 4 molecular compounds. All right, let's have a look at these ones. So for number 1, we got nitrogen and we got iodine. So what would we call this stuff? Do I need a prefix on the nitrogen? No, there's only one. It's first. We don't put a prefix on that. So this is going to be nitrogen. What's the prefix for 3? Tri. Okay. Now for this, I think, again, I'm not an English major, but I'm pretty sure you need a hyphen there, okay, between the 2 vowels, triiodide. Otherwise it looks silly because you get 2 I's right beside each other. Okay, so nitrogen triiodide. Right, so remember, in a molecular compound, the first element doesn't get its name changed. You write it exactly as it appears on the periodic table. It's only the second element that ends in "ide." Okay, I see that as a common error with molecular compounds. People write nitride triiodide. Okay, no, only the second one ends in "ide." Okay, all right, number 2. Okay, we're starting with carbon. Okay, what's the prefix for 4? Tetra. Okay, again, probably needs a hyphen. Tetraiodide. Okay, and the third one, do we need a prefix on nitrogen? We do. Okay, which prefix? Di. dinitrogen trioxide. Probably need a hyphen there too. Okay, dinitrogen trioxide. Yep. All right, and then our last one here, we've got tellurium. Do I need a prefix on that? Okay, we write it exactly as it appears on the periodic table, tellurium, and then what prefix is going on astatine? Di. All right. Try the rest of those. Give you a few minutes on the rest of them. All right, for number 5, what does P stand for? Phosphorus. Okay, so what prefix needs to go in front of that? Di. Okay, diphosphorus trisulfide. Okay, what about number 6? Do I need a prefix on the oxygen? Nope. Okay, so this is just going to be oxygen. Then what do I need? Mono. Sulfide. Okay. For number 7, what's Si? Silicone. Okay, do I need a prefix? Whoop. Okay, what's the prefix for 4? Tetra. Okay, trisilicone tetraphosphide. Okay, remember we're only changing the second one, right? In number 8, do I need a prefix on the sulfur? Okay, this is going to be sulfur. What prefix do I need on the chlorine? Dichloride. Okay, and then number 9, silicone is a single, so I don't need a prefix on that one because it's first. Okay, and what prefix is going on the hydrogen? Tetra. And how do I write the hydrogen if it's second? Hydride, right? Behaving as a non-metal in that case. Okay, and then for number 4, okay, we've got number 10, tetraboron, okay, and tricarbide. That would be the abbreviation for carbon is carbide. All right, so are those feeling familiar? Okay, now here's the challenge. Every list you've had so far of practice questions has been, these are ionic. These are ionic and need Roman numerals. These are molecular. Now I'm going to throw you a list where you have to figure out which set of rules applies. That's how it would work in, actual quizzes or lab situations or things like that. Okay, so just a quick review. How can I tell if it's ionic? What will it start with? One metal, one non-metal, or one metal and a polyatomic ion, right? So always going to start with a metal. If the first thing you see is a metal, it's an ionic compound, okay? If the first thing you see is a non-metal, then you follow the molecular rules, okay? But that's got to be able to tell those apart. All right, so let's start out with, let's say, the first 10. Okay, so write down the question, but also write down the answer. If you need some help, let me know. Okay, let's look at the first 4, just to make sure we're kind of on the right track here. All right, number 1, is that ionic or molecular? Ionic, yeah. Lithium is a metal. Okay, so we follow our ionic naming rules. We write the name of the metal. Okay, lithium. We write the name of the non-metal, ending in "ide." And then when we're done, we check if Roman numerals are needed. Do I need Roman numerals for this one? Nope. Lithium only has one possible charge, so I'm done. Okay. Number 2, Cr stands for? Chromium. Is that a metal? Yeah, chromium's a metal. Okay, so we're looking at an ionic compound. Okay, so chromium. Write the name of the metal. Write the name of the non-metal, fluoride. Okay. Does chromium have more than one possible charge?
Yes.
Yes, so this one is going to need a Roman numeral. Okay, fluorine is in group 17 where everything has a -1 charge. There are 3 fluorines for a total of 3 negative charges. That means chromium must have the +3 charge. So this is chromium 3 fluoride. Guys, when I give these as quiz questions, forgetting Roman numerals or over-applying Roman numerals are probably the 2 most common mistakes on ionic compounds. Okay? Some people just forget to do them entirely, and other people put them when they're not required. Okay? I don't know what it is about them, but the easy way is just check. Okay? Look at the periodic table. If it's got more than one number there, then it needs it. Okay, number 3, ionic or molecular? That one's molecular. Phosphorus and bromine are both on the right side of the staircase. Okay, do I need a prefix on phosphorus for this one? No. All right, so we got phosphorus. Do I need a prefix on bromine? Which one? Okay, phosphorus tribromide. All right, number 4, ionic or molecular?
Ionic.
Ionic. Zinc is a metal. Okay, so we follow the naming rules. Zinc. Iodide, does zinc have more than one charge? No. Zinc is always a 2+, okay? So no Roman numerals are required on this one. Okay, any questions on the first 4? All right, keep going. All right, number 5, ionic or molecular? It's molecular, yeah. Okay, silicone is a non-metal. All right, so this is going to be silicone. And what prefix am I putting on the oxygen? Yep, dioxide. All right, for number 6, ionic or molecular? Molecular. Carbon is also a non-metal. Okay, so we've got carbon. And what prefix am I putting on the sulfur? Okay, tetrasulfide. All right, number 7. What is TC? Yeah, technetium. Okay, it exists in nature in only extraordinarily small amounts, most of which is produced either in red giant stars or by the spontaneous fission, that's radioactive decay of uranium. Okay, it has been made in particle colliders, but it is extraordinarily rare. Most of the technetium that exists on Earth is man-made, okay, in either nuclear reactors or particle colliders. It is just something incredibly unstable that just doesn't stay in nature for very long. Okay, but it's on the periodic table, so we put it in here. Okay, technetium. Okay, and it's ionic, obviously, because technetium is a metal. Okay, so this is just technetium iodide. I find with that one, there is such a desire to put a prefix on that because it's a big number. It just feels like it needs one, but it doesn't. Okay, this is just technetium iodide. All right, and then for number 8, there's our first one that has what in it? A polyatomic ion. All right, so it's obviously an ionic compound. Sodium is a metal, okay? And if there's a polyatomic ion, it's definitely an ionic compound. So this would just be naming the metal, sodium, and naming the polyatomic ion, hydroxide. That was our first example yesterday of one that contained a polyatomic ion. Okay? That is the active ingredient in oven cleaner. So if you've ever sprayed the white foamy stuff on the inside of the oven, that smell, that's sodium hydroxide. Okay? It's also in lye. Okay? So yeah, really caustic, corrosive substance. Okay, how many people have done number 9? All right, okay, let's go over number 9. Okay, so another one that's got the polyatomic ion. I put a bracket around it. Didn't need it, but I put it there. Okay, Ca is calcium. And what is SO4? Right, sulfate. Okay, I did have a couple people who asked, do I go sulfate-ide? Nope. Okay, polyatomic ion, you just write it as it appears in the box on the top of the periodic table. All right, number 10. Ionic or molecular? Ionic. It has a polyatomic ion in it. Okay? Now, K stands for potassium. Right? And what is MnO for? Permanganate. Yeah. Permanganate. Okay. Potassium permanganate's weird stuff. In the Korean War, they actually used it as a fungicide. They would put it on like soldiers' feet to keep like athlete's foot and other fungi from growing inside their boots. Okay, it is little purple crystals. It's actually quite pretty when you look at it. It's just little tiny little shard-like purple crystals. Okay. However, it is highly soluble in the oils on your skin, which was why it was great for preventing the growth of fungus on people's feet, because it would dissolve easily and then it would, slow the growth of fungus. It had a side effect though. Once it gets on your skin, it turns brown, like quite a dark brown. So if you have a very fair complexion, okay, you're going to see it as soon as you touch it with your bare hands, okay, which is where this next story comes in. Okay, I once had this kid years and years ago, like now we're talking 23 years ago. Okay, we did a lab with potassium permanganate. First instruction was, guys, don't touch the potassium permanganate with your bare hands. He never, ever listened, ever. And sure enough, 5 minutes later, he's got the dish, and he's like, got his fingers right up to the first knuckle in this stuff, and he's like, Coder, this stuff's really cool. And I just looked at him and said, yeah. And I watched him continue to do that for a while, and this guy was like pasty, okay? Like his complexion was super pasty. And I'm like, hey, look at your fingers. And up to the first knuckle was dark brown. Like, where were your fingers? Dark brown. And it doesn't come off. You can't wash it off. It's a stain. His fingers were like that for weeks. Okay? Didn't teach him to listen any better, unfortunately, but it was kind of funny to watch him walk around with the tips of his fingers all brown. Okay. So you should listen to me when I tell you stuff, otherwise I'll let bad things happen. Okay, let's have you guys try the last few here before class is out. Okay, so up to 15. Give it a few minutes on those. All right, let's have a look at these here. Okay, so for number 11, ionic or molecular? Molecular, they're both non-metals, so this will be nitrogen. What prefix goes on the oxygen? Mono, right, so, or just mon in this case. Okay, nitrogen monoxide. Okay, number 12, ionic or molecular? It's actually ionic. Yeah, beryllium is still a metal, right? It's box 4 there. Okay, so this is beryllium cyanide. Okay, polyatomic ion cyanide is often known as the kingmaker. Anyone know why? What's cyanide used for? Murder. Okay, it's a poison. Okay, very common poison. It was very common for in medieval times for an heir to poison the king so that they could become the king. It's called the kingmaker. It's a very common poison. Okay. All right, and then 13, kind of same idea. Instead of beryllium now, though, it's barium. Yeah, it doesn't change kind of what we do there. Okay, this is just barium cyanide. Incidentally, cyanide poisoning. You can taste bitter almonds if you are poisoned with cyanide. There is a distinctive taste of bitter almonds. So if you ever eat something and it's suspect and you taste bitter almonds and it's not actually almonds, puke. Okay? Yeah, you don't want to die of cyanide poisoning. Well, of anything really, but cyanide poisoning is also bad. Okay, number 14, ionic or molecular? Okay, it's ionic, sodium is a metal. Okay, this stuff you probably have in your kitchen. Anyone know what the common name for sodium hydrogen carbonate is? Or sodium bicarbonate, it's sometimes called? That is baking soda, yeah. All right, PO4, ionic or molecular? Okay, it's molecular. How many people named this phosphate because it's in polyatomic ions? Okay, if you did, that's okay, it's an honest mistake, okay? But unless PO4 has a metal in front of it, it's a molecular compound, okay? So this would be phosphorus tetra oxide. That happens a few times. Some of those polyatomic ions can exist as a compound, a molecule by themselves. So unless they're in a compound, you name them like they're a compound on their own. Okay, good job today, guys. Make sure you check out those quizzes and the solutions. Come in and see me for help before it's too late.